All right, guys, our next section is going to be talking about limits. It'll be probably, hopefully, the last section we're going to do, last concept we're going to do. So limits is like one of the first things you're going to talk about in calculus. Limits are going to help us find what we're going to call derivatives. Derivatives are a major concept of calculus that we need to know, and this is like the introduction, the basics to us. All right, so if f of x becomes arbitrarily close to a unique number L as x approaches c from either side, then the limit of f of x as x approaches c is L. All right, that's how this reads. This reads right here. The limit of f of x as x approaches c is equal to L. And L is the limit, which is your answer. So it's the limit of f of x as x approaches c is going to equal your limit. We're going to have several different ways, and we need to be able to do each way. There's not just one way that always works, except what we're going to do today. The other parts can be done, not always, but most sometimes can, sometimes can't. So what we're going to do is we're going to make a table. And what we want to know is we want to find a y value, which is going to be our answer, which is our limit of the limit of 4x minus 3 as x approaches 2. So what's happening is we're going to have a graph and the idea. Okay, here's a basic graph. What I want to know is what my y value is as I approach the value 2 from both sides of the graph. So, all right, so here's my value 2. All right, I want to know as I go from the left side and I get closer and closer to 2, and I come from the right side and I keep getting closer and closer to 2, what value of y is my graph getting really, really, really close to? Understand, it does not have to get there. All it has to do is get close to it. All right, so I'm looking for as I go from, follow my graph from the left and go towards x equals 2, and I come from the right and go to my x equal 2, what value of y is my graph getting close to? And hopefully we can see as I come this way, because I'm trying to get to this point right here, or something really, really close to that point. As I go this way towards that point, all right, so as I follow my graph towards x equals 2, what value of y is my graph getting close to? And hopefully you see that's 5. Times we're going to be able to look at it and tell. Other times we're going to have to be able to do other math. So what we're going to do is we're going to make a table. And what I want to do is I want to approach 2 from both sides. I want to keep getting closer and closer and closer and closer to 2 without really getting there. And the numbers we're going to use. All right, so if I want to approach 2, I'm going to get close to 2 on both sides. Like 1.999 is really close to 2. 1.99 is a little further away. 1.9 is even further away. But I want to go from 1.9 to 1.99 to 1.999, getting closer and closer. If you wanted to go further, you could go 1.9999999 and keep going. And that's approaching it from the left side. Now from the right, we're going to do the same kind of steps. 2.1, 2.01, 2.001. All right, so I'm going to take these 5 values. I'm going to substitute them into the x value. And I'm going to do the math. And this would be calculator. We're not going to do this by hand. We use a calculator. So 4 times 1.9 minus 3 is 4.6. 1.99 gives me 4.96, 4.996. Coming the other direction, if I plug in 2.1, I get 5.4. 2.01, I get 5.04. 2.001, I get 5.004. So as I am going from both directions towards that value 2, what value of y is my graph getting close to? And we're going to say it's 5. And that would be my answer. So the limit of 4x minus 3 as x approaches 2, as I keep getting closer and closer to 2 from both sides, my y values are getting closer and closer and closer and closer to 5. Understand, it never, ever, ever has to get to 5. It just has to get close to 5. All right, let's look at another. All right, so the limit of x plus 3 over x squared plus x minus 2 as x approaches 2. So what we're going to do is I'm going to graph this first, just so you can see what's going on. And this is my graph. All right, so as I follow this graph towards my x that equals 2, which would be my x equals 2 is right here. As I follow this graph, and I follow this graph, are they going towards a single value, which is going to tell me what my y value is? And hopefully you realize when x equals 2, this one keeps going up, 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 up. And from the left, it goes down, 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 down. So they're not going the same. So if we made a table and I want to approach 2 again, I'm going to use the same values. 1.9, 1.999, 2.1, 2.01, 2.001. All right, so I'm going to use these numbers. As I come from the left side, and I get closer and closer to that 2, these numbers keep getting smaller and smaller and smaller. Negative 10, negative 100, negative 1,000, negative 10,000 keeps going. As I come from the other direction, 2.1, 2.01, 2.001, I get 10, 100,000. And we need to realize they are not going towards a single value. And since these graphs are going away from each other at x equals 2, we're going to say this limit does not exist. Or we can also write DNE, does not exist. Because as I look at this graph, as I approach 2 from both sides, my graph is not going towards a single value. It's got to go towards a single number like this one did. They were both going towards that y value of 5. All right, let's look at the next one. Limit of cosine of x, subtract 1 over x. All right, I cut out the rest of the graph, but this is what it looks like. All right, so as I come from the left and the right, and I approach 0, is my graph going towards a single point? Yes. Does it have to get there? No. All right, so making my table, I'm going to approach 0 this time. So I'm going to do the same steps. Negative 0.1, negative 0.01, negative 0.001, because I'm approaching 0. Then 0.1, 0.01, 0.001. All right, so looking at these numbers, 0.0499, 0.004999, scientific notation, so I move my decimal place 4 places to the left, 0.0005, in this situation. What value of y is this graph going towards? Hopefully looking at the graph and look at these numbers, these keep getting smaller and smaller and smaller. So we're going to say this limit equals 0 because it's going towards 0. But if we do this real quick, if I do the cosine of 0, subtract 1 over 0, I can't divide by 0. So if I plug 0 into this function, that point at 0 does not exist. But that doesn't mean the limit doesn't exist because I don't have to get to 0, I have to get close to 0. So the cosine of x is 0, is 1, minus 1 is 0, so I got 0 over 0. Later, that's going to be a good thing. 0 over 0 is a good thing when we talk about limits. It means there probably is a limit, we just have to do a different way. All right, but for this one, when I make my table, I can't just plug 0 in because it doesn't work, but both sides, as I go towards 0, my graph is approaching 0. All right, so what I want to know is I'm going to get closer and closer to 0. Negative 0.1, negative 0.01, negative 0.001. 0.1, 0.01, 0.001, keep going. This is almost 0, this is almost 0, and these keep getting closer. All right, piecewise function. All right, hopefully we know when I make my table, and those are my numbers over here, I'm approaching 2 from both sides. So when my x is less than 2, I'm going to go 1.9, 1.99, 1.999. When my x is greater than or equal to 2, I'm going to go 2.1, 2.01, 2.001. So these numbers that are less than 2 would go into here. The numbers that are greater than 2 would go into here. So I'm making my table, and you can do these on Desmos, that's fine, or your calculator. What do you got? I get this. All right, so I put 1.9, 1.99, 1.999 into the top, 2.001, 2.01, 2.1 into the bottom. And as I look at this table, this is getting smaller and smaller, this is getting smaller and smaller, so my limit of f of x as x approaches to is going to equal 0. We don't have to get there, we just have to get close to it. All right, so I'm making a table. These are the steps. We're going to be off by 0.001, off by 0.01, and off by 0.1. You plug these numbers into the function, look at the table, and figure out what's going on with your y values. Are they approaching a single value? If they are, that value is the limit. All right, we have three situations. The limit of f of x as x approaches c does not exist if one of the following conditions are true. F of x approaches a different number from the right side of c than it approaches from the left side of c. So as I come from the left and the right, they're going to two different places. F of x increases and decreases without bounds as x approaches c. That means as I go towards that c value, my graph is going to keep going up, 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 up forever, or down, 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 down forever as I get closer to that value. And the last one says f of x oscillates between two fixed points as x approaches c. Think of an oscillating fan. It goes back and forth. So as I keep getting closer and closer to C, my graph keeps bouncing up and down. All right, so let's look at these. We're going to have three reasons. All right, we're going to put A, B, or C, and I'm just going to draw arrows to make it work for me. All right, so the limit of 1 over x as x approaches 0, this graph is right here. So as I approach 0 from both sides, from the left side, my graph keeps going down. From the right side, my graph keeps going up. They are not going towards a single value. They're going two different directions, going up forever and down forever. So we're going to say that this limit doesn't exist because the graph increases and decreases without bounds as x approaches c. That's the same situation we had back here. They're going up and down forever. We said it doesn't exist because they're not going towards a single value. All right. The cosine of 1 over x is this graph. If you look at it, it goes down, up, and starts bouncing around, and starts going back and flattens out again. All right, we're going to say that this limit doesn't exist because it's not really going towards a single value. It's bouncing back and forth. So we're going to say that it's letter C oscillates between two fixed points. It keeps going up and down, up and down, up and down. It's not going towards smoothly towards a single value. All right, and the last one, change this up and clean it up a little bit. All right, this is what we have. All right, from the left side, it's flat at a horizontal line at -1. From the right side, it's a horizontal line at +1, and it stops at 0. So the limit of absolute value of x over x as x approaches 0. As I go from both sides, are they going towards a single point? I would say no. From the left side, it's approaching -1, and it's at -1. And the right side is approaching +1. So we're going to say that f of x approaches two different numbers from the left and right side as x approaches c. It's going two different places, so it doesn't have a limit. All right, now, looks a little confusing. It's not that bad, so I'm going to give you two limits. Limit of f of x as x approaches c is going to equal some number L, and the limit of g of x as x approaches c is going to equal some number k. What we're going to do is some basic math by taking the limit of two functions that are add, subtract, multiply, divide, whatever. Something's done to them. All right, so first one's going to be my scalar rule. If I take the limit of b times f of x, some number b times that f of x function as x approaches c, all I'm going to do is I'm going to multiply b times that answer. So if I have the limit of something, and this answer is 7, if I take the limit of 2 times that something, my answer is going to be 14. So if I multiply my function by some value, some scalar b, you multiply the answer times b. All right, sum and difference. F of x plus g of x, the limit of f of x plus or minus g of x as x approaches c. I'm going to take f of x, is answer, L, g of x is answer, k, and add them or subtract them. Same idea for multiplication. Limit of f of x times g of x as x approaches c. I'm going to take this answer, multiply it times that answer, L times k. Division. Limit of f of x over g of x as x approaches c. I'm going to take my f of x limit, L, divided by my g of x limit, k. Again, just basic rule, remember, can't divide by 0. And the last one's a power. If I take the limit of f of x raised to the nth power as x approaches c, I'm going to take my answer and raise it to the nth power. So we're just doing this math that's inside. We're taking the answer and doing the same math as on the inside. All right, so there's some function f of x and some value c. So I'm going to take the limit of that function as x approaches c, I get the answer 5. And the limit of g of x as x approaches c, my answer is 6. I don't really need to know what f of x and g of x is. I just don't need to know what c is. It's the limit of that function as x approaches c equals 5. And the limit of g of x as x approaches c equals 6. Yeah. So if I want the limit of negative 4 times g of x as x approaches that value c, all I'm going to do is I'm going to take negative 4 and multiply it times the answer, which is 6. You get negative 24. So I'm going to take that scalar, multiply it by the limit of g of x as x approaches c's answer, and do the math. Limit of f of x minus g of x as x approaches c. All right, that's going to be this rule. All right, so I'm going to take the f of x and g of x as two answers and subtract them. So I'm going to say limit of f of x is 5 minus the limit of g of x, which is 6. So I'm getting the answer of negative 1. So the limit of f of x minus g of x as x approaches c is negative 1. All right, and the last one for today, the limit of f of x to the third as x approaches c. Same idea. Take my answer for the limit of f of x as x approaches c, raise it to the third power. Get an answer of 125. So the back page, the last page we had, looks a little more confusing than it is. We're just doing the math on the inside with the answer for the limit of g of x and the limit of f of x. All right, so that's first lesson. I will be posting the second lesson probably later today. It should be up by Monday afternoon, and these will be due on Sunday night. All right, hope everybody's well. If you need any help, let me know, and have a great day.